Good morning, class. Today we're going to talk about acids, bases, and salts. So let's first ask ourselves, what happens when you combine an acid and a base? Well, if we think about it, acids and bases are already in a solution, so they're going to undergo dissociation. So let's see what ions each of these dissociate into. The H2SO4, hopefully we recognize that this is an acid, because it begins with H, is going to dissociate into H plus ions and into SO4 2 minus ions. Our other solution here, the other thing in solution here, is magnesium hydroxide. Hopefully we can recognize that this is a base because it ends with OH. It's going to dissociate into two things. It's going to dissociate into OH minus ions, and it's going to dissociate into magnesium 2 plus ions. Now when you combine them, there are some things that are nice and easy. Hey look, an H plus and an OH minus, what would happen if they get together? They turn into H2O. Two H's, one O. Turns into water. And that just wonders, well, what's the other thing? I have SO4 2 minus, I have Mg2 plus. Those are going to combine. Those charges are already balanced, so that makes our life a little easier for this one. Remember, you always write your metals first. So it's going to be magnesium sulfate. Well, what are these products? H2O we already know. H2O is water. And we have this particular name for something like magnesium sulfate. Magnesium sulfate is considered a salt. If I'm not mistaken, I think that's actually Epsom salts, the same sort of thing that you might put in your bath. So the reaction that is between an acid and base has a special name. We call it a neutralization reaction. And it's because the neutralization reaction has two key results. One key result is that the pH moves towards 7, and 7 is neutral. Oh, that makes sense. The next is that the products are always a water and salt. A neutralization reaction makes water and salt. So what we have here is we have an acid plus a base is going to make water and salt. So what is a salt? Well, salt is any ionic compound that's made from a positive and negative ion that's not H plus or OH minus. There are a couple other exceptions, but for the most part, we're looking at almost all ionic compounds are salts. So, and salts can have a variety of different features. Sodium chloride is a salt. That's actually a regular old table salt, and it tastes salty. Nickel chloride is green, and that's pretty interesting. Magnesium dichromate is an orange salt. This is sodium acetate. Sodium acetate is actually the primary flavor in salt and vinegar chips. So how do we identify whether a reaction is a neutralization reaction? Well, you can either look at the reactants and see that there is an acid or a base. Remember, acids start with H, bases end with OH. Or you can look at the products and you can identify that there's water and a salt. Let's put that into practice. Let's take a look at this first example here. I see it starts with H, so I know it's an acid. And if I were to consider, I know this separates into the H plus ion, and I know it separates into the F minus ion, because those are the two pieces that break down. And I see that NaOH is a base because I see it ends with OH, or my hydroxide ion. And it means that it would dissociate into the sodium ion. There we go. I know this is a neutralization. Here's the thing is I also know my neutralizations always make water and a salt. Now, the only trick is to figure out, well, what is the salt? Take a look at those ions that aren't the H and the OH. That's going to be the thing making your salt. So I have F minuses and NAs. Remember, always write the positive ion first. So it's going to be NaF, sodium fluoride salt. There we go. I've just completed this neutralization reaction. Thing is, we could go the other way around. Look at the second example. I have nickel chloride and H2O. Well, H2O is easily recognizable as water. And nickel chloride is an ionic compound. It's a salt. Well, that means I had to have had an acid and a base react to make it. Now, working backwards might be a little trickier, but it's still doable. The salt is going to break into its parts. There's nickel, which has a 2 plus charge in this case, and there's chlorine, which has a 1 minus charge. What does the water break down into? It breaks down into hydrogen plus ions and hydroxide ions. Now we ask ourselves, okay, which things will combine? Well, the nickel plus ion can combine or can recombine with the OH minus ion. That would make nickel hydroxide, or this is our base. And this chlorine minus ion will combine with the H plus ion, making HCl, or if we remember our naming rules, hydrochloric acid. Now you probably notice that this is not a balanced equation. This is still a skeleton equation. That's okay, because now that we've identified the parts, we would be able to balance this if that's what we wanted to do. All right, that's all for acids and bases and salts right now. Have a good day.